Afternoon to all of you. Welcome to my new series. The series name is Master Arduino Like a Pro. In this series, we are gonna learn the basics of Arduino programming, and we over here in sisyaclass are there to help you with how the programming of Arduino is actually done. Thank you so much for joining this video. We'll be moving ahead and we'll see that what we have ahead. So firstly, let me introduce myself to you. My name is Ahmed Sir. I am a coding and robotics coding expert. I have done my graduation and post-graduation from the University of Mumbai, and I am MSc IT and B.Ed. At the same time, I am a senior master teacher at sisyaclass with a complete of 12 plus years of experience in various different technologies, be it coding or web development or robotics. Right, and so here I have brought you this series where we will be learning Arduino together. Right, moving ahead, as you know that I am from sisyaclass, we would really like to welcome all of you to sisyaclass and be part of this family as well. So let me quickly give you a rundown of all the sessions that we have planned for you, so that you can be and different pins that we have for connection, and at the same time we'll do a basic programming. Okay, and we'll catch on this topic in the next slide. Okay, tomorrow, and we have we have all the sessions scheduled throughout the week. Every day we will have one session covering one important aspect of Arduino programming. Tomorrow, that is 18th of March, we will see that how voltage regulators are connected in Arduino Uno for reliable circuits. And the next day, 19th March, we will see that how to connect and use temperature sensor with Arduino Uno. Okay. On 20th March, Arduino motion detection, we'll see that how motion detectors are actually used. On 21st March, we'll see that how to power and control a DC motor. Finally, the last day of this week is 22nd March, where we will be incorporating all the knowledge, all the concepts that we have learned so far throughout the week, and create a capstone project. In this capstone project, we are going to create a motion activated cooling system which is specially dedicated for pets, and this will be special projects which can be created by people who have pets at their home and they love their pets a lot. So as I have mentioned, this is the entire schedule for this series, and today we are going to cover the very first topic where you will be moving ahead with your first step of professional programming. Well, without further ado, let's get started. What are we going to do in today's session? In today's session, we will see introduction to Arduino. We'll see that what Arduino Uno is actually, what are the different pins that this board comes with, and how we can use this to do programming as well as robotics at the same time. Second, we'll have an introduction to Tinkercad, because Arduino Uno is a physical device, and I know that all of my viewers might not have a physical device with them to experiment with. And therefore what we are going to do is we are going to use a simulator. So a simulator is a software that mimics a real life object. In this case, the simulator that we are going to use is Tinkercad. So Tinkercad will basically mimic an actual Arduino. This will give us the ability to use Arduino without having an actual Arduino device. Alright. Third thing that we're going to do is we are going to create a blinking code. Okay. A very simple and easy to use, easy to make project that we are going to work in today's session, but this will give you a very good insight on how programming in Arduino is actually done. So guys, give me a thumbs up if you're all with me. Let's move ahead. So first thing first, we'll talk about Arduino Uno board at the first place. So the Arduino board that we are going to talk about, it comes with a various different types of board. We have Arduino Mega, we have Arduino Mini, Arduino Uno. The board that we are going to use in today's session is Arduino Uno. So if you are in India and if you want to buy this board, this Arduino board will cost you somewhere around 400 to 600 rupees depending upon from which vendor you are buying it from. Alright, okay, so you can get it very easily. You basically need to use this board and connect it with your laptop using a micro USB cable. Usually the cable comes along with the Arduino board as a complete set. Alright, Once you get this physical device, this is how your Arduino Uno board will look like. Okay, now just to give you a brief summary, and we'll talk about all of these pins in very great detail in the upcoming classes as well. Okay, but just to give you a brief summary, that the first pins over here that you will see, which are numbered from 0 all the way up to 13, that means a total of 14 pins. These pins are labeled over here as digital, and I've mentioned over here also digital. So one portion or one side of the Arduino Uno board consists of all digital pins. Okay, remember these are digital pins. I'll explain in the next slide that what digital pin actually is. Okay, coming to the right opposite side of digital pin, you will see some pins which are numbered as 0, 1, 2, 3, 4, 5, but the difference is every number over here is subscript with A. Okay, so it has a prefix of A in these numbers. A over here stands for analog pins. They are analog pins. So we have two different types of pins over here. One is digital pin, the second one is analog pin, and I want all of you to keep this in mind. Okay, so we have a total of 14 digital pins, and we have around 6 analog pins. Okay, these two pins, we'll talk about this in the coming slide. Apart from that, we have power pins. Okay, now these power pin will actually, and as the name suggests, it will give power to your devices, to your sensors, to different components that you will be connecting to Arduino for, depending upon what kind of project you want to create. Okay, so basically the power that these components would be requiring to function, this power will be acquired by the power pins from the Arduino pin. Okay, and basically we have two different types of voltage outputs in Arduino board. The first one is 5 voltage, which will give you an output of 5 volts, and then the other one is labeled as 3.3V, which, as the name suggests, will give you an output of 3.3 voltages. Alright, I believe this is clear so far, right? Moving ahead, how would you program this board using your computer or your laptop? You basically will need to connect this using a micro USB cable to your computer or a laptop, and that wire will be connected over here. This is called as the power jack. It can also be considered as a USB connector too. Okay, so the USB connector itself can act as a power jack too. Okay, then we have the reset button. Reset button is basically to reset the Arduino board and make the Arduino board run the entire program from 0 once again. Okay, it's basically like you clicking on the restart button. I believe this is clear to all of you, right? Drop a comment in the chat section if you have any questions. I'll be there to solve all of that. Okay, let's move ahead. So I want you all to remember the location of each and every pin. We are going to talk about what these pins are meant for in the next slide. Okay, but take a screenshot if you want any. All right, done. Let's move ahead. Okay, so as I mentioned that we are going to talk about the next thing, which is the pins. Okay, so I mentioned about 3 different types of pin. One is digital pin, the second one is analog pin, and the third one are the power pins. Let's try to talk about this in detail. Okay, so firstly we'll talk about digital pin. Okay, and to keep things very simple, let's remember this: digital pin will either be on or it will be off. Okay, let's keep things very simple. Okay, digital pins will be either on or it will be off. Okay, now what does on or off means? It means that whether the current will be supplied or the current will not be supplied. Okay, that's it, nothing apart from that. And if you create the graph of this voltage coming from the pin, from the digital pin, you will see that the graph will look something like this. This graph is actually called as a square wave graph. It is called as square wave graph. And if you see over here, all the lines which are below or bottom, they represents 0 voltage, and all the line which is on the top is considered as high voltage. So we have either we have voltage or we'll have no, have no voltage or we'll have high voltage. That's how it is. Okay, so we have low voltage, high voltage, low voltage, high voltage, low voltage, high voltage. That's how you can use, square wave diagram to represent a digital signal. Okay, So if you see, there is nothing which is in between on or off. There is no point which is between this line and then this line. Okay, let me quickly draw it for you. You will see that there is no line. See, this is one line. There is nothing which is in between over here, right? And that's what digital pin actually is, or digital signal actually is. Either it will be high or it will be low. It is either there or it will be not there. So when we want to send signals related to this kind of information, that case we will be using digital pins. Okay. Also, when we want to send binary data, now when we say binary data, it is streams of ones and zeros. Okay. So you will have streams of ones, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So this will be considered as a binary stream. So whenever we want to communicate with the board or the sensor using binary stream, in that case the pin that we are going to use is digital pin. Okay. So two places where we will be using digital pin. One is where we want to have either something to be on or off. The second where we want to stream binary information. I hope this is clear to all of you. Okay. Let's move ahead to the next point. The next point over here is analog pin. Okay. Now analog pin are actually used to interface analog output. Now what does analog output means? Analog output means that it can be a value which is continuous. It's not either this side or that side the way it was for digital pins. Analog pins can be between any maximum and minimum value. For example, if you see, this is how sine waves are actually represented, and this is how sine waves are actually represented, and this is how we call this as a analog signal. Okay, and an analog signal is represented by a sine wave. As I mentioned, digital signal are represented using square wave. Okay, if you see over here, this is the highest value and this is the lowest value, but the value can be any number between the highest and the lowest. We'll consider this as the max value and we'll consider this as the min value. So we have max value and we have min value. The value of our sensor or our board can be between any max and any min. So if let's consider that this value, the max value over here is 5, okay, and the minimum value over here is, let's say, 0, for example. Okay, which means that I am not only limited to either 5 or 0, but I can use any other value, or we can get any other value which is between 0 and 5. So that can be 2.5, it can be 1.7, it can be 3.8, any of these numbers can come. So if this is within the range of the max and min. So this is the difference between the analog signals and digital signals. Analog signal, you can get any values between the max and min value. But when it comes to digital signal, you can either get max or you can get the minimum value. That's the major difference between analog and digital signal. Now if you ask me, where do we use analog signals? So when you use sensors which senses real life object or any type of or any form of energy, in that case we will be using analog signal. For example, if you want to sense how loud a sound is, the sensor that you will be using will give you values in analog signals. The same goes with the light intensity, the same goes with temperature, the same goes with humidity as well. Okay, so all of the sensors and most of the sensors that you can use to sense a real life energy form will be in the form of analog signal. Where would you use a digital signal? Where you want to turn a switch on or off, or if you want to transfer a binary data from one point to another. In that case you will be using digital signals. Okay, coming to my last type of pin, which is power pin, and I've already mentioned that we have two types of voltage outputs. One is 3.3 voltage and the other one is 5 volts. Okay, the third one that I'm talking about is ground, usually abbreviated as GND in your Arduino board. GND stands for ground. Now you can consider that ground is like a drain of current. For example, when you take a shower in your bathroom, wherever the water falls on the floor, it flows and goes to the drain, right? Likewise, using the same analogy, you can understand this, that when you supply current to a circuit, after reaching to all the component, it should be drained so that the circuit is complete. So the place where it is getting drained, the pin, or we can also call it as a negative pin, is actually termed as ground. Usually the voltage of ground pin is 0 volts. Okay, so we can consider ground pin as the negative pin. I hope so this is clear to all of you, right? As the negative pin. Yep. Alright, I believe this is clear to all of you. Great. Fine. Alright, so now since we have talked a lot about the theoretical aspect of Arduino and we understood the basics of Arduino, it's time to move ahead to Tinkercad. Okay, as I mentioned, the simulator that we're going to use in today's session is going to be Tinkercad. It gives you the ability to do robotics and do Arduino programming without the need of having a physical device bought from the market. Okay, so we are going to use Tinkercad. What I want all of you to do is to just make sure to move, to open a new tab and then search for tinkercad.com. okay, so if you open a new tab in your browser, okay, and trust me, it works well with laptops and computer but doesn't work too much well with mobile phones. Okay, in tabs it will work fine. Okay, so if you have a laptop computer, please proceed ahead with me. So we have over here a new tab and I can simply type for tinkercad.com. okay, this is the website. Tinkercad.com is the website's name. Once it is done, you hit enter and this is the dashboard that you will get. Okay, if you are a first time visitor, you will need to create your account. It's a very straightforward and simple process. I don't think that I need to cover that. Once you create your account, if you are first time user, this is the landing page that you will see. Okay, now once you get this landing page, this is basically the home and you will see all the projects that I have created or you will be creating up ahead over here at one place. Okay, now if you want to create a new project, you will click on the create button over here. It will ask you 3 different types of information, whether you want to create a 3D design or circuit or code block. In our case, we are interfacing with robots and therefore we will be creating a circuit project. I'll just click on circuits. Okay, once I do that, I'll get this kind of interface. Now this portion over here is actually called as a workspace. Okay, this is called as a workspace. So basically every component that you will be using in your project will be placed over here. So anything which is over here is something which is used in your project. Okay, all the electronic components that you can use in this software or in this platform can be seen in this component bar, or we also call it as a toolbar. Okay, so you can see resistors, LED, push buttons, potentiometer, Arduino, all that sort of things. Okay, and the best thing is that it's super easy to use any of the components which are there in the toolbox. Let me give you an example. Let's say for example, I want to take the Arduino Uno in my project. Okay, anything which is over here is in my project. Anything which is over here is not in my project. Okay, so I want to take Arduino Uno. So what I'll do is I'll drag it and drop it over here wherever I want, and that's how easy choosing a component and placing the component in your project is. Okay, so that's how you add a component in your project. Right now in my project I have one component, that is Arduino Uno board. Okay, I believe this is clear to all of you. And if you see, the pins are exactly the same thing that I've already mentioned. Digital pins over here, analog pins over here, power pins over here. Okay, all the pins are mentioned as we have seen in the previous slides. Okay, now moving ahead to the next part. Once you select this board, here you will have a lot of tools that you can use to modify and customize your project. For example, you can flip it, you can rotate it, and you can set it in any orientation that you would like to, or else if you're not happy, you can just click on undo to get it undone, right? Fine. So this is how you can rotate stuff. You can in fact also mirror image also, vertically flip or horizontally flip it. This can be done for other components, not for Uno. Then you can also add annotations. Annotations are nothing but labels. So when you create very complex circuits, it's sometimes really difficult to keep a track of each wire and each pins. So therefore we write some notes. These notes are considered as annotations, and you can add annotations using this one. If you want to delete any component, you can just select that and then click on the dustbin icon. That will be deleted from your project. Okay. Apart from that, if you see, we have code toggle button. If you click over here, you will see the place where you can write your program. Okay, we'll come back to this in a moment. And then if you want to start your project, right now the project is just there, it's not started. Okay, but if you want to start your project, you will click on start simulation button, and basically this program will start running. And if you see, this small LED on the Arduino's board is actually blinking. This is an indication that the project is running. Okay. Fine. I'll click on stop simulation to stop the simulation. Okay, and then we'll do the programming for it. Okay, let me quickly get this done. Hold on. Yeah, finally we got it. Okay, moving ahead. Now, if you remember, what we were supposed to do is, we were supposed to create a project where the Arduino Uno will be programmed to blink an LED, isn't it, right? So we'll get that done very quick. So I'll place my Arduino Uno over here, and then I'll take the LED from here. Okay, so now we have two things together. So we have the LED and the Arduino Uno. Now how the connection will be made? The connection can be made using wires. Okay. Now one thing to make sure is that LED is a polarized component, which means that it has a negative terminal and a positive terminal. Negative terminal will always go to ground, as I have mentioned, that ground can be considered as a negative terminal, and then the positive terminal can go to any of the digital pins. Okay, it can go to analog pins also. We will cover this in the next class. Okay, but today we are going to use digital pins to turn the LED on or off. Okay, so now if you see, the shorter leg of the shorter terminal of LED is actually the cathode. Cathode is nothing but the negative terminal. What you can do is, you can just drag a wire from here and add it inside the ground. That's how the connection is made. And if you are not happy with the wire color, once the wire is selected, you can just click on it and change the color. I prefer negative wires to be black, so that it's easy for me to track the ground wires. Okay. However, color doesn't matter at all when it comes to the flow of current. Okay, color is just for our preference. Okay, moving ahead, we will be connecting the anode to pin number 10. Okay, and since this is a positive terminal, I'll click on red. Okay, so now what I've done is, I've connected the LED with the Arduino board. Okay, however, if I click on start simulation, this will not work. You know why? Because we have not commanded or instructed the Arduino Uno to do what with this pin number 10. Okay, so that's what we are going to do right now. Okay, we are going to do the programming. The instructions to the Arduino board is actually given by coding, and now we will be starting with the coding part. Okay, the connection is already made. So I will click on code, and now we have two different options. For small kids and for beginners, we can start with block-based coding, where the coding is already done. All you need to do is just drag and drop it and place it at the right place. Okay. However, for people who already have some level of experience in programming, or if you are a grown-up student, right, in that case what you will do is, you will use text-based coding. Okay. However, before moving directly to text-based, let me open block-based and text-based both together. Now if you see, if I click on this drop down, you will get three different edit modes: block plus text, and then text. Okay. Now right now I have selected block plus text. Okay, here we have block based coding, and exactly corresponding to it we'll have the text based coding. Basically they both are the same thing, represented in different way. So people who are young in age or completely beginner can start from here. People who have some level of experience or you are a grown up, then you can start from here. Okay, today what we are going to do is we are going to cover the text based code, because in the coming classes we'll do much more complex programs. Okay, by the way, the programming language that we are using for Arduino coding is actually C++. So basically when you're doing Arduino programming, basically you are learning C++ programming. Okay, now in order to completely switch to text based code, what you will do is you will click on this drop down and then click on text. You will get an alert message saying that if you change the code into text, you cannot bring it back to block based. Are you sure? So if you're sure, you can click on continue, and that's how your block based coding will go away. Okay, and this is a code that is already given for us as a reference that was working with Arduino Uno, and this code was actually responsible for this small LED to blink. Right, I believe this is clear to all of you, right? I'll click on stop simulation for now, and this is how we get it. Okay, moving ahead to code once again. Now what I'll do is I'll modify this code in a way that my LED that I have connected will blink rather than the inbuilt LED we had. This inbuilt LED is actually called as LED built-in Arduino programming, and you can see this term mentioned over here, LED built-in, LED built-in, LED built-in. Okay, we don't want the LED built-in to blink, we want our pin to be blinked. What is the number of pin? Comment in the chat section. Okay, the pin that we have is 10. So what we will do is I'll move this, I'll take my cursor to pin mode and remove LED built-in and put the number as 10. So right now what I'm saying is I'm saying that hey, I'm telling to Arduino board, hey, why don't you keep pin number 10 as an output pin, which means that you're instructing the computer or the Arduino board that pin number 10 is the pin from where the current will move or will emerge. Okay, moving ahead to the next point. Then we have the second thing as void loop. Okay, now void loop is a function, or you can say is a a code block where if you write something inside void loop will repeat again and again innumerable times. What line of code will you write over here? Something that you need to do repeatedly. For example, sensing the temperature. For example, checking if the motor should be on or off. Or for example, if you want to turn the LED on and off continuously, right? So all the actions that you want to happen repeatedly will actually go inside void loop. Okay, talking about the first one that we have is void setup. Void setup is a function or a code block which will run first but only once. Okay, the first function that gets executed in Arduino program is actually void setup, and this will run only once. So instructions that we want to do only once will be placed over here. For example, connecting Wi-Fi, connecting your Arduino board with your Wi-Fi, or setting the mode of all the pin, or establishing a serial begin connection, right? All of these things will come inside void setup. I'll repeat this once again. Things that you want to do only once will be inside void setup. Things that you want to do multiple times will be inside void loop. What would happen if you change or you replace the code which is there in setup and you will add it inside loop? Well, it will still work. The only problem is it will work multiple times rather than having only once, and it will not make sense because it will just take additional computational power and it will take up your energy also, energy from the power source. Okay, therefore we'll make sure that the correct line of code is at the correct function. Okay, now moving ahead, coming back to my void loop, here we have digital write. Digital write is actually a command which tells the Arduino that hey, make the changes in this digital board, okay, or digital pin. Then I need to tell that what changes I need to make and where should I make the changes. So first of all, I need to send or give the pin number. How will you write the pin number? We'll first of all remove LED built-in which was already there, and here what I'll type is the pin number that I want to change the state of. In my case, I've connected the positive end of the LED to pin number 10, and therefore I want to change the state of pin number 10. Okay, so I've written digital write pin number 10 set as high, which means I'm telling the Arduino board that hey, in pin number 10 set the voltage of that pin high, which means that the LED will turn on. I hope this is very clear and very straightforward too, right? Okay, then moving ahead, we have delay. We have delay of 1000 millisecond. Now delay will make the program stop and take a pause, and this number over here will define that how long this pause will be. 1000 over here refers to 1000 millisecond, which is equivalent to 1 second, which means that once the LED is turned on, then the LED will be in that state for 1 second. And then moving ahead to the next line, we have digital write, and then again we'll change this pin number and we'll change it to 10. And then again I'm saying that digital write, that change the state of this digital pin to low, and the pin number is 10. Basically this line is saying that change the state of pin number 10 as low, which means that voltage will be low, there will be no current, and if there is no current, which means that the LED will turn off, right? So that's how you are turning the LED on and turning the LED off. With every change in state, you have a delay of 1 second kept in between. Like you can see over here, right after low, we have delay of 1000 milliseconds again. Now the best part and the beauty of void loop over here is that this thing will keep on repeatedly happening again and again, which means that it will turn on high, turn on again, wait for 1 second, turn off, wait for 1 second, then again turn on, wait for 1 second, turn off, wait for 1 second, until when it will happen? It will happen till the time you have this simulation running. I believe this is clear to all of you, right? Just to see if this code is running or properly or not, we can click on start simulation and you will see that the LED should be working fine. However, you can see that there is an additional image coming over here which shows that there is something going wrong, and in next session we are going to solve this as well. Okay. However, if you can see this LED, the LED which was not blinking previously is now blinking. I hope so this is clear to all of you, right? Okay. So finally we were able to achieve our objective for the day, and we'll go back to our slides now. Moving up ahead. So yeah, our objective was to make the LED blink, and we were finally able to do that. Now that's everything for today. In the next session, what we're gonna do is, in the next session we're gonna create another Arduino program, and this time we will interface with the analog pin, and we'll see what is the difference between interfacing with a digital pin and an analog pin. Okay, the title of the session is how to use voltage regulators with Arduino Uno for reliable circuit, and the session is tomorrow at the same time. So stay tuned, make sure that you are subscribing the channel and hitting the bell icon to not miss any notification. Moving ahead, make sure for these kind of updates you are downloading the sisyaclass app from the App Store or the Google Play Store. It's available. You can just open the App Store or Google Play Store, search for sisyaclass app and download the application for more fun educational videos and classes. Okay, moving ahead, make sure that you like, share and subscribe the channel so that you're not missing on any important updates from us. We have wonderful sessions lined up for you, and you will be able to learn a lot of things when it comes to coding, robotics, physics, maths and all the subjects that you have in your schools as well. So till then, stay tuned. Tomorrow we'll be meeting in the same time. Thank you so much, and thank you so much for being such a wonderful audience for me. Bye bye, take care.